Okay, so right now I'm going to talk to you about, let's say that we collected some data and we've graphed it. And the question is, well, now that we have that data, what should we do with it? Like, what's the, what do we do at this point to understand it and to get meaning from it? Okay, and so I'm going to kind of point you to one way to take information from data, and this is something we'll do quite a bit this year, and so that's why I wanted to just kind of start off with a little video on it. But before we start finding information about this graph right here, I'm going to show you just kind of some general types of graphs. Things that we want to do when we're collecting data and analyzing data, we want to see if we can find some type of mathematical relationship. And so before we look at that set of data for a mathematical relationship, I'm just going to kind of go over some of the different kinds, just as a refresher. You probably are familiar with them. So you might have something that's linear, or the graph looks like a straight line. Okay. And it could also be have a negative slope, so maybe something like this. Okay. You could have something that is parabolic or quadratic. And that wasn't a very good one. But along those same lines, you could have any kind of polynomial. You could have something that is a power function. You could have something that is a square root function. You could have something that is an inverse function. Let me go ahead and put the kind of parent functions in there. So this would be like y equals mx plus b. This would be something like y equals x squared. Or this could even be like y equals ax squared plus bx plus c. This would be maybe like y equals 2 to the power of x. Okay. This might be y equals square root of x. This might be then y equals 1 over x. And then a couple other kinds you might run into, like a inverse squared function, which would be like the inverse, but maybe would like hug a little bit closer to the axes. And then the other thing that you might run into is a logarithmic function. So it can look something like this. Okay, that'd be maybe y equals log base 10 of x. And if you're interested in just kind of experimenting and playing around with graphs and stuff, a great place to go is an app called Desmos. Many of you are probably familiar with it, but then you can graph stuff and tweak things and see what they look like. And we'll also be using it to analyze data later, but for now we're going to do it by hand. So we're going to go ahead and go back to that other set of data now, and I want you to think about which of these types might be a fit for what we have. Okay, so what kind of data do you think this is? Do you think it's linear, quadratic, a power function, inverse function, square root function, logarithmic function? What do you think this is? Well, I'm gonna hopefully say you said that it looks linear, because it looks pretty linear. It looks like it could potentially have a little bit of curve to it, but I think it doesn't look to me like there's enough to draw any conclusions from it. So we're going to draw a best fit line, and we're going to make it linear. Okay, and when we do this, we want to make sure we have lines above and below it. This best fit line is kind of splitting through them. Okay, so I'm going to draw it. It's nice to use like a straight edge or some kind of ruler or something when you do it. Looks like this maybe. Let's see, go there, get back. Alright, oh, it's going to be gold. Alright, I can't get it to change the color. So anyway, here we have our best fit line. Now we've drawn that, what do we do with that? Well, what we want to do is we want to go ahead and write an equation for it. Okay, so that remember the parent function for a linear function is y equals mx plus b. You could also use point slope form. Okay, and that's totally up to you, whatever you're more comfortable with. So the first place we start is with the slope. And when you're using the slope, you got to pick 2 points, and the 2 points that we're going to pick, they need to be points that are on the line. Okay, so like I can't pick my data points. Like let's say I pick those two that are on the line. Potentially you could pick these two, but it's a good practice to pick new points once you draw the line. So the data points are here, and we use them to draw our best fit line. And then once we've done that, we kind of replace them with the best fit line. Okay, so I'm going to make 2 new points for our best fit line. We'll say this one is about 2 and about, so we'll say like 3.5. And we'll get another one maybe somewhere like right here. We'll say about 6, comma, maybe 6.2. So 6, comma, 6.2. Okay, and that first number represents hours, because that's what it says on our lower axis here. And the second number is going to represent some number of apples. Okay, and so now to find slope, we can do rise over run, so how much we go up over how much we go over. Or you could actually use the slope formula, y2 minus y1 over x2 minus x1. So that would be like 6.2 minus 3.5 on the top over 6 minus 2 on the bottom. And one thing that's important here is to include the units. So the y values were apples, and the x values were hours. Alright, you can also do it this way. From 2 to 6 is 4. From 3.5 to 6.2 is going to be 2.7. So that's 4 apples and 2.7 hours. Alright, and then we divide them, so you could subtract those there too instead if you preferred. 2. I have these backwards. This is 4. That's 2.7. So 2.7 apples in 4 hours. We go ahead and divide them, and it looks like we're going to get about 0.675 apples per hour. Okay, and now that we have our slope, we're going to go ahead and substitute into one of these functions and solve for, just kind of fill in the rest. Okay, before we do that, I'm just going to clean up some of this real quick. Erase everything. Here's our slope right there. We're going to go ahead and write the equation for our line now. You can use either of these forms. You could use this one, y minus, and we could pick one of these points. Let's go with this lower one. So 3.5, and those were, the y values were apples, equals 0.675 apples per hour times x minus, and that was 2 hours. Okay, now from here, remember that we want to, I prefer to have it in this form right here, so we're going to go ahead and solve for that. It's important, as I was saying, to include your units because it helps us to interpret. But also what we want to do is we want to make this equation fit this graph, okay? And so this is not a y-axis, this is the apples axis. So we're going to change this y to a capital A, and this axis represents time. So we're going to change this to a t, okay? And so now we're going to do some simplifying. I'll distribute that. We'll get A equals, I'll add the 3.5 over 0.675 apples per hour times t minus 0.675 times 2 is going to be, I believe, 1.35. Let me check that. Yeah, so we multiplied these two right here to get that, and I'm multiplying these two. This times that is 1.35, and then you can see the hours. It's going to multiply those hours to leave us just with apples. and then we have a plus 3.5 apples at the end. Okay, so to fully simplify it, the function says that A is equal to 0.675 apples per hour times T plus 1.75, no, and this would be 2.15 apples. Alright, so the last thing we'll do real quick is we'll do some interpretation. So this 2.15 apples is referring to our starting place, our intercept here, the amount of apples that we started with. And then the number of apples increased at a rate of 0.675 apples per hour after that. And this, I mean, this is just random numbers and quantities that I came up with. This works for any kind of quantity and any kind of thing that we're analyzing. Whenever we have a linear function, we can make an equation for it, and we can use it to make predictions. So if I wanted to ask, say maybe, well, how many apples will it be after 10 hours? You could substitute 10 and solve for A. At the same time, you could say, well, how long will it take for it to be 25 apples? You could put 25 for A and then solve for T. Okay, so this opens up some things that we could do to make predictions.